Okay, this is integrating in spherical coordinates, and I'm Jody DeVoe. Okay, so let's take a look at our first example. Okay, this is the problem. The directions here say integrate. Integrate. So I think it's pretty obvious that we don't, if we possibly can, we don't want to integrate this in rectangular coordinates. It doesn't look like something that would be particularly nice to integrate in rectangular coordinates. Okay, so I'm going to first figure out what is the region of integration that we're talking about, and then once we figure out what the region is, we'll switch it over into spherical coordinates or cylindrical coordinates, whichever seems most appropriate. Okay, so let's start with the first inside integration. So it says I want to start at z equal negative square root of 1 minus x squared minus y squared. It's z equal that because that's my first integration variable here is z. So I'm going to start at z equal negative square root of 1 minus x squared minus y squared, and then it's supposed to go up to z equals 0. Okay. Notice that this integration region then, whatever it is going to take place all below the xy plane because z is negative and it goes up to z equals 0. Z equals 0 is the xy plane. So, as I said, whatever region this is, it has to take place completely below the xy plane. Okay. Now, I'm going to try to mess around with this equation z equal negative square root here and try to recognize it as a surface that I know. So I'm going to square both sides. So I get z squared equals, and when I square the right hand side, I'm just going to get z equals 1 minus x squared minus y squared. And then rearranging some things here, I see that's x squared plus y squared plus z squared equals 1. And that's a sphere of radius 1, centered at the origin. Okay, so now I know I've got a sphere of radius 1, but as I said before, because I'm starting at z equal negative square root there on the bottom and only going up to z equals 0, I know I'm talking about the bottom half of a sphere so far. Bottom half of a sphere. Now, that's what the z limits are telling me. The x and y limits are going to add some more to this and perhaps limit that bottom half of the sphere even more. So I need to take a closer look. But this is what I have so far, the region that I have so far. So this is y, here's x, and there's z. And so far, I know I am integrating the bottom half of a sphere. Okay, so that's kind of where I am so far, the whole bottom half of that sphere. Now, as I said, the x and y limits will limit this some more. So now that I've got it down to the xy limits, I'm going to focus then on what's going on in the xy plane. Okay, so I'm not worried about the three-dimensional situation here anymore. I'm just focusing on what's going on in the xy plane. So now I look at my next limits out, the y limits, and I see that the y limits are going from y equal 0 to y equals positive square root of 1 minus x squared. And again, I'm going to work on the second equation here and try to figure out what that is in 2 dimensions. So I square both sides. I get y squared equals 1 minus x squared, or simply x squared plus y squared equals 1, which I recognize in 2D is a circle, radius 1. Okay, but it's not the whole circle that we're talking about, because as I see here, this is starting at y equals 0 and going up to y equal positive square root of 1 minus x squared. So y is never negative. So in the xy plane then, what I've got so far is the top half of this circle. Okay, the top half of the circle starts at y equals 0 and goes up hits this edge here, and that edge is the square root of 1 minus x squared. Okay, so it's the top half of the circle. But it's further limited because x is going from x equals 0 to x equal 1. So from x equals 0 to x equal 1, well, that means I'm just talking about that little quarter of that circle in the xy plane. So from this, I know I'm talking about in the xy plane, just the region where x and y are both positive. Okay, so what does that mean then relative to that half a sphere that we were talking about before? Well, I'm only looking at the bottom half of the sphere and only the bottom half in which x and y are both positive. So that means I'm looking at this region here that's underneath that quarter circle in the xy plane, and I'm going to only look at then this eighth of a sphere. Eighth of a sphere. Okay? X and y both positive, z all negative. Okay, so let's see then if we can change this now into spherical coordinates. So in spherical coordinates, here's my 3 integrations. I'm looking for a volume, so I'm integrating just one. Here's my dv, which is rho squared sine phi, and then d rho, d phi, and d theta. Okay, let's hit rho. Okay, so rho is the distance from the origin out to the sphere. So in our case, that's going to go from 0 to 1. But again, we're only talking about that first eighth of a sphere. Okay, so let me see if I can draw that maybe better. Maybe not. Let's give it a try here. Here's x and y. And what I'm talking, and of course there's z. So what I'm talking about is just this part of the sphere that's under here. Okay, so this is hitting 1 all the way around. So that's why rho is going from 0 to 1. Now phi, let's think about phi. Phi has to take place, the whole surface here is below the xy plane, so that means that phi has to start in the xy plane and then go down to the negative z-axis. So to get phi to start in the xy plane, remember that phi is measured from the positive z-axis down. So from the positive axis, z-axis down into the xy plane, that would be an angle of pi over 2. So I want to start my phi angle at pi over 2 and let it go all the way down to get to the negative z-axis at pi. Okay, so starting in the xy plane, that's my pi over 2, goes down to pi, that takes it all the way down to the negative z-axis. Now what about theta? Well, I don't want theta to go all the way around because I don't have the whole half sphere. I only got a part of it, only the part that's in the xy, positive x, positive y, the first quadrant of the xy plane. So theta in the first quadrant would have to go from theta equals 0 to pi over 2. Okay, and that gets that first quadrant theta angle going. Okay, and then of course you'd integrate from here. Okay, so we're just focusing on the setup. Okay, so this was rho, distance from the origin out to the center. Phi, that's the thing that gives you pretty much the bottom half of the sphere. So we started at pi over 2 and went down. And then theta, theta is the part that's controlling what part of the bottom half of the sphere you want. You only want the first quarter of it, the part that's only in the first quadrant of the xy plane, so theta's got to go from 0 to pi over 2. Okay, hope this helped.